Today we will review for the first quiz in Unit 1. In the 2007 season, baseball player Alex Rodriguez hit 54 home runs in 583 at-bats. In the 2007 playoffs, he hit 1 home run in 15 at-bats. Create a bar graph to compare these performances and describe what you see. So 54 home runs in 583 at-bats is 9.3%. 1 home run in 15% is 6.7%. So this would be the 2007 season, and this would be the 2007 playoffs. So you can see that he hit more home runs during the season than in the playoffs. Here are the results for the first 10 free throws of the 2013 regular season for Rajon Rondo. Calculate his overall free throw percentage after each shot. So the first one was a miss, that's 0 out of 1, which is 0%. We have another miss, 0 out of 2, 0%. A make, 1 out of 3, 33.3%. Another miss, 1 out of 4, which is 25%. Another make, 2 out of 5, which is 40%. Another make, which would be 3 out of 6, or 50%. Another make is 4 out of 7, or 57.1%. Another miss is 4 out of 8, which is 50%. We have another make, 5 out of 9, 55.5%, and then another make, which is 6 out of 10, or 60%. If we were to continue this process for all the free throws, what will happen? So the percentage will level off due to the law of large numbers. And it will level out around his ability. Over his football career through 2008, quarterback Peyton Manning completed 64% of his pass attempts. Explain how to use a spinner to simulate Manning's performance in a football game where he attempts 34 passes. So we're going to create a spinner. With 64% labeled complete. And 36% incomplete. Then we're going to spin it 34 times. and track the number of completes. Then we're going to plot it on a dot plot and repeat many times. So they did 100 simulations and found that it ranged from 14 to 30. And it says, in this context, explain what it means to have an ability of 64%. And we would say, if Manning were to play in the same conditions indefinitely, we would expect him to complete 64% of his passes. So in the 100 simulated games, what was his best performance and what was his worst performance? So his best performance was 30, and his worst was 14. So if his actual game, he attempted 34 and completed 25, would that be surprising? Well, if you look up at the dot plot, you see 25s right here, right in the middle of the range. So we would say no. 25 is within the range of the simulation. If he completed only 10, would that be surprising? Well, 10 would be somewhere way down here. So the answer to that would be yes, because 10 is not within the range of the simulation. How many completions would he need to give you convincing evidence his ability increased? So you're going to look at the highest number, which in this case would be 29. We would say he would need more than 29 or more than 28, or 29, sorry. And the reason why is because 29 is the highest number within the simulation. If we decide his ability has changed, what are some possible reasons? As long as you don't tell me it's because aliens abducted him or he found out that eating grass like cows helped a whole bunch with his performance, then we're pretty good. You could say He did weightlifting. You could say he got a new coach. You could say he went on a better diet. There are all kinds of things. As long as it makes some sense, it's all good. Just make sure on a question like this where it gives you an open-ended number of answers, look at the number of points. If there are 3 points, give me 3 answers. Suppose that a basketball player has the ability to make 75% of her free throws. The following dot plots show the results of 100 sets of 53 free throw attempts and 100 sets of 200 free throw attempts. What is the value in the middle of each distribution? Well, if you look in the middle, you could count and find out about where 50 is, but 50 for the most part is going to be somewhere in here. And for this one, 50 would probably be somewhere around here. Well, we said her ability was 75%, so it's not surprising because it is close to her ability. Which one shows the results of 50 free throws and which one shows the results of 200 free throws? This one's kind of tricky. Remember, the law of large numbers is going to say they're going to be more compact. It's going to be more centered around the actual ability. But these look roughly the same. The one on the right might even look a little more spread out. However, if you look at the numbers down on the bottom, the one on the right is actually closer by range. So the left is 50 free throws because it's more spread out. And the right is 200 free throws because it's more compact.